It's the sum or the difference of cubes. So we're going to do difference of cubes first. Okay, so again, this is one of those things where it's just a special factoring that we may do this once, and then honestly, it may not pop up again until you get into pre-cal. And I have seen some people that use this in pre-cal, so it's just one of those things of kind of knowing that it's there, so that when you get to pre-cal, that it will still kind of be, hanging around. Okay, so basically, we're gonna do something like this. Let's say it's x to the third minus 8. All right, now in your mind, here's what you got to think of when you get one like this, where you got x to the third minus 8. You've got to think that this is x to the third minus 2 to the third. So you got to think about what that number is that would be cubed. So we've got x to the third minus 2 to the third. Just that 2 times 2 is 4, and then 4 times 2 is 8. Okay, so it always should be some number to the third power, as we're going through this thing. Okay, so you've got to figure out what it's got to be some number cubed. So you got to take this number and just break it down. So it's going to be 1 times 1 times 1, or 2 times 2 times 2, or 3 times 3 times 3. So it's always going to be some perfect cube number that you're thinking about. And the thing is with this one, that when you go through this, there's only basically kind of give it to you the formula. Let me give you the basic formula of it back here. That if it's a cubed minus b cubed, the formula says you're going to do a minus b, and then you're going to do a squared minus whatever a times b is, and then plus b squared. Okay, and once you do this part of it, it's one of those things that you break it down, and that's it. There's nothing else you can do, because it seems like there's a lot you could do with it, but there's really not. That once you do this one little thing, that's it. So for this part of it, everywhere we've got a, we're going to replace it with x. Everywhere we've got b, we're going to replace it with a 2. So that means if we do x to the third minus 2 to the third, that's going to be x minus 2 times x squared minus, and we're going to do a times b, in this case x times 2, but instead of doing x times 2, we'll just do it like 2 times x, because that's where we're most of the time used to seeing it. And then plus, we're going to do 2 squared. 2 squared would be 4. And I know somebody's thinking, well, shouldn't we then go back and find the factors of 4 that equal 2? There are no factors of 4 that's going to equal 2, so this thing is as far as it's going to go. So that's going to be your final answer. And I know somebody's thinking, but we can do more. No, that's as far as it goes. That's it. That's all you can do. The only other thing you could do from this part of it is if you were going to solve, you would set this equal to 0 and get this one answer. Then you would have to take this a, b, and c value and plug it into the quadratic formula to find out what that answer would be. So as far as factoring goes, that's all you can do. It seems like you can do more, but that's it. Question. Yes, but if you're ever doing difference of cubes, it will never factor once you get to that point. That's as far as it's going to go. So this is the final answer to that problem right there, and that's all you can do. Okay, so if it was y to the third minus 125, okay, we're good with y to the third. 125 would be 5 to the third. So again, everywhere you've got an a, that's going to be a y. Everywhere you've got a b, that's going to be a 5. So it's going to be y minus 5. Instead of a squared, that's going to be y squared. And then we're going to do a times b, which means we're going to do y times 5, or 5 times y. Oh, wait, I'm sorry. Let me back up here for a second. That's supposed to be a plus sign. My bad. And that should be a plus sign there. And then at the end, that would be 5 squared. That would be 25. Okay. I was looking at that. I was like, wait, something's not right. I left something off there. Okay. And that's I know it's saying, and again, I know you get here and you're like, okay, but we can do more. But the way the formula is set up, that's all you can do. And it seems like you can do more, but that you just cannot do more to get there. Okay. And then the toughest thing that you're going to have to do with one of these is that instead of it just being one number, it may be that you may have something like, well, actually, yeah, we'll go ahead and do it here. Let's do 8x to the third minus 27. Okay, so we know it's x to the third, but it's 8x to the third. So if we start looking at what that would be as far as cube numbers go, that's going to be 2x to the third. And then 27 would be 3 to the third. Okay, and the first parenthesis is always pretty easy because it's just these two numbers minus each other. So it's just 2x minus 3. Okay, then it should be the second thing squared. Now, in this case, though, when we do the second thing squared, it's 2x squared minus, and then 2x times 3. Sorry, plus. And then plus, not that we really need it here, but it's 3 squared. Oh, sorry, it's 2. That's parentheses around the 2 there. Sorry about that. There you go. Sorry about that. Okay. So if they give you a number with that first term, that makes things a little bit more complicated because of you've got to go through and kind of think about that you've got to actually simplify it a little bit. So in this case, it's 2x squared. It's not just x squared, but it's also 2 squared. So this would be 4x squared. And then when we do 2x times 3, that's going to make that a 6x, and still do 3 squared to make it 9. Okay, and again, it seems like you can do more with this second set, but there's nothing else you can do with it, unfortunately. Okay, and then the other one we're going to do here is the sum of cubes. The good thing is with sum of cubes, the only thing that's different is that you change two signs. So if you have a cubed plus b cubed, if they just set this up where there's no numbers and it's just two variables, it's going to be a plus b, and then it's a squared minus ab plus b squared. Okay, so the only thing that's different between the sum and the difference of cubes is that these two signs here basically just get reversed. That when we're doing the minus up here, it was minus positive. This time it's going to be positive negative. And the last term is always positive, no matter which case you go. So really it's the same formula, just changing the first two signs, just changing those up. So if it's the sum of cubes, it's the same thing as the different ones. If we give you, Let's see what we can do here. Let's go with x to the third plus 64. So we've got x to the third. You've got to rewrite 64 as something cubed. In that case, that would be, 4 cubed. Okay, so that's just going to be x plus 4. Okay, where you got x, you're going to replace it with a. Wherever you got b, you're going to replace it with 4. Then it's x squared minus a times b, but in this case, that's x times 4. But again, we're used to putting the number first, so we'll put that as 4x. And then plus b squared, 4 squared would make that out to be 16. Okay, and again, it seems like you could do something with this, but there's nothing you can do with this one because the only thing you can do then is if they ask you to solve it, you would set this equal to 0 and you would use a quadratic formula, which is not going to be a lot of fun, but that's about the only option you have once you get there. If they talk about doing binomial expansion, which basically means there's two different ways you can do it. To me, this is a much easier way to do this one. Pascal and his buddies way back when, this is back when everybody used to just sit around and think and do a bunch of stuff. They started, just to kind of give you an idea of what we're talking about here, that doing this with binomial expansion. We've got the steps that's here. Again, just want this kind of written down so you can see everything that's here. That basically we're going to use this row of numbers, Pascal's triangle that we've got. We're going to take the first term in descending order, second term in ascending order, and then multiply all this other stuff to get here. Here's basically where this set of numbers came up from, Pascal's triangle. You don't have to write this down. You just kind of watch for a second. We'll show you what you got to write down. That they were sitting around just thinking through stuff, trying to figure out what was going on with it. And they were like, okay, what if we take the shortest, easiest binomial we've got and we try to write this thing out and see what it would look like if we keep doing powers on it. So like, okay, let's do x plus 1. We're going to do it to the 0 power. And again, I don't think we're quite here yet, but we said, if y'all remember from last week, we said anything to the 0 power is 1. We'll come back and talk about that a little bit later because we haven't talked about it yet. We'll get there. And they're like, all right, well, let's take x plus 1 to the first power, which would just be x plus 1. And they're like, okay, let's do x plus 1 squared. So then we're going to do the full method where we do x plus 1 times x plus 1. And we're going to come out, that's going to be x squared plus 2x plus 1. Okay, and then they did x plus 1 to the third. And they were like, okay, we're going to take this answer we've got here. And then once we got this answer, we're going to do this answer times this. And we're going to do the full method again. And we're going to run through all this stuff. But then we figure out that this thing is going to come out to be x to the third plus 3x squared plus 3x plus 1. Well, then they all started sitting around figuring this off, and somebody was like, well, wait a minute, wait. If we kind of build this thing like a little bit of a pyramid, notice these first numbers are always 1. It's 1x plus 1. It's 1x squared. It's 1x to the third. And then somebody started realizing, they're like, well, hey, to get this number, we can do 1 plus 1 to get 2. And they're like, well, then we can do 1 plus 2 to get 3. We can do 2 plus 1 to get 3. And no matter how many times we do a power of 1, whether it's 1 squared or 1 to the first or 1 to the 0 power or 1 to the third or 1 to the fourth, this answer is always going to be 1. And okay, well, let's see if this works. So they took this answer they had, they multiplied it by x plus 1, and they were like, well, would that be the same answer as if we took 1 plus 3 to get 4? We take 3 plus 3 to get 6 and 3 plus 1 to get 4. But now we're going to do x to the fourth, x to the third, x squared, x to the first, and we go back and do this. And then they realize, they're like, hey, that shortcut works. So if we want to get the next row of numbers, instead of having to take this answer and then do the full method again, we can put a 1 here. We can do 1 plus 4 and get 5, 4 plus 6 and get 10, 6 plus 4 and get 10, 4 plus 1 and get 5, and we're just going to put a 1 at the end of it. And we're going to start with x to the fifth, And then we're going to have x to the fourth, and x to the third, and x squared, and x to the first, and we got a 1 here. And they're like, hey, we got a shortcut. But then you always need that guy in the group or that girl in the group that somebody's going to do something. They're going to go, all right, genius. What if instead of doing x plus 1 to the power all this stuff, what happens if we do x plus 2? That you always need that buddy that keeps you in check. That when you think you're really smart and they go, all right, genius, what happens if you do this? Right? You get this great idea and they're like, all right, somebody builds something and like, oh, I got this thing and we can use it somewhere and this will do this great thing. And you're like, all right, but you're out in the middle of the woods. How are you going to get an extension cord long enough to get it there? And you go, oh, well, so then you got to have that. Somebody says, all right, genius, here's what you got. So here's basically what it was. This is a shortcut. Instead of doing x plus 2 to the 10th power and doing the full method over and over and over and over and over, here's a shortcut that we can do to do all this stuff without having to do the full method over and over and over and over and over and over and over. Okay, so to do this, what we're going to do is we're going to have a number like x plus 2. We're not going to do the 10th power. That's going to be too big. But let's just say we were doing some number. And here's what you need to write down. So let's start with something like this. Let's start with x plus y. Let's do the 5th power. All right, so story time's over. Now we're actually doing some real problems here. So they kind of hang with us for this one. And these shouldn't take too long to get through this. We'll do maybe 2-3 examples because that's about all the time we got. Okay, so what we're going to do to expand using binomials, using Pascal's triangle, says the first thing, we're going to just kind of keep this triangle here because that's why we got it to make it go a little bit quicker, is we're going to write down the row of numbers in Pascal's triangle where the exponent expression is the same as the second number. So if this is x plus y to the 5th, you've got to find the row of numbers that's got a 5 in it. So that's this row right here, the 1, 5, 10, 10, 5, 1. So when you write these numbers down, don't write them right beside each other. Spread them out. Give yourself plenty of room because we're going to do all the work underneath here. So find the row of numbers that's got this number, this power. Take that number out and use that row of numbers. You're going to take the first term and start counting down with this power. So it's going to be x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0. And then it says you take the second term and start counting up, but start at the 0 power, and then do the 1st, to the 2nd, to the 3rd, to the 4th, and then to the 5th. Okay. And if you do that, here's basically what it is. This is the first term of your answer. If you draw a line between the numbers, that's your second term, your third term, your fourth term, your 5th term, and then your 6th term. Okay, if you get one that's all variables, it's actually easier than having some numbers in it because the only thing you have to do is if you have x to the 0 power, you can just scratch that out and put a 1 there. And just like if you have y to the 0 power, you can scratch that out and put a 1 there also. And then you just multiply all your terms top to bottom. It's 1 times 1 times x to the 5th. So that is x to the 5th. It's 5 times x to the 4th times y to the 1st. So that's 5 x to the 4th, y to the 1st, or just y. And then it's 10 x to the 3rd, y squared. And then it's 10 x squared, y to the 3rd. And it's 5x y to the 4th. And then we've got 1 times 1 times y to the 5th, which is just 1 y to the 5th. Okay, so this is supposed to be a shortcut to doing the full method over and over and over and over and over, because if you try to do the full method with that x plus y, all the X's and Y's start getting really confused and it gets jumbled up and there's stuff everywhere. So in this case, if you do it this way, it makes everything kind of neat and organized because everything in one column is basically your first term, second term, third term, fourth term, that kind of thing. Okay, so if it's just two variables, it's actually pretty easy because it's always just going to be these numbers, and then it's your powers of x's going down and your powers of y that go up. Okay, let's go back to the one we're doing just a second ago that we're talking about here. Let's do x plus 2. We'll go to the fourth power just to make sure we've got plenty of time to get it in. Okay, so we're going x plus 2 to the fourth. Okay, and it's three things you've got to do. The first thing is it's x plus 2 to the fourth. So you find the row of numbers that's got a 4 in it. So that's 1, 4, 6, 4, 1. So we're going to use that row of numbers here for Pascal's triangle. Again, don't cram them in. Leave plenty of room because you're going to have to work everything underneath it. All right, so is everybody okay where we got that row of numbers and why we're using that row of numbers in particular? Okay. And then it says start with the first power, or the first term, and count down with this starting with this power. So start with x to the fourth, x to the third, x to the second, x to the first, and x to the 0. But again, we know it's 0 power, so you can go ahead and kind of scratch that out and just make that a 1. Okay, and then we're going to do the same thing, but now we're going to take the second term, which in this case was a 2, and you're going to count up with the powers. 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and then 2 to the fourth. Okay, and then just draw lines in between it so you keep everything kind of neat and organized. All right, now if there's any good thing about the numbers, here's where you can kind of go through and scratch this off one time. If you do 2 to the 0 power, anything to the 0 power, if you want to kind of scratch that out a little bit, that's 1. 2 to the first power, that's just 2, right? 2 squared is 4. 2 to the third, don't get second rate. Don't think 6. Remember, that's 2 times 2 times 2, so that's 8. And then 8 times 2 is 16. Again, to go from one number to the next, it's just this times 2 times 2 times 2 times 2. So you just keep going by whatever that number is that you got here. Just keep multiplying by that number. So you start with 1 and you just keep multiplying by that particular number. Okay, so now you've got 1 times x to the fourth times 1, which is just x to the fourth. You got 4 times x to the third times 2. 4 times 2 is 8. X to the third. We've got 6 times 4 for 24. X squared. We've got 8 times 4 for 32. X. And then 16 times 1 is just 16. Okay. Now, there's also another way that's called binomial theorem that you can actually do the same thing, but to me, it's a whole lot more complicated than this. But to me, that's just the easiest way to go back through and get the numbers or something like that. Okay, one more. Let me just show you this one because I got to show you one with a negative. Everybody's good there? All right, one more with a negative. Let's go with x minus, and the numbers won't be that big just because of how long it would take. I'm going to go back to the fifth power just because I'm afraid if we do 6, it may get too big and we may run out of time, so let's just go fifth power. Unless you're okay with doing the sixth power. We can do 5. All right, we'll do 5. Okay, 5 it is. Okay, so again, we need the row of numbers that's got a 5 in it. So that's going to be 1, 5, 10, 10, 5, and then 1. No, I've just got it right here in front of me. Okay, again, start with the first term and count it down. 5, 4, 3, 2, 1, and then we have liftoff. Again, for that one, you can go ahead and scratch that off and make that a 1 because anything to the 0 power is 1. Okay, now, and for now, just ignore the negative for a minute. We're just going to worry about the number. We've got 3 to the 0 power, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and then 3 to the fifth. Okay, and I always tell people when you're doing this one, I would go ahead and just scratch these numbers out on the bottom that's got a number. Go ahead and tell me 3 to the 0 power is 1. 3 to the first power would just be 3. And then just keep multiplying by the 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 would be 243. Okay, and then just start multiplying everything together. Now, here's what we're going to do for these, though. Wait on your signs for a minute. Just put all the numbers, and we'll go back and show you how the signs work. We've got 1 times 1 times x to the 5th, which is just x to the 5th. 5 times 3 for 15, x to the 4th. 10 times 9 would be 90, x to the 3rd. 27 times 10 is 270, x squared. 81 times 5 is 405x. And then 243 times 1 is 243. Okay, and the only thing you do different is if there's a minus sign in the middle like this one is, the first term will be positive, second term is negative, positive, negative.
Good morning, Sparkle Senators. Will you please stand for the Pledge of Allegiance?